In section 1.2, we're going to look at data classification. Generally, there's two types of data. We have qualitative data, which is data describing things using attributes, labels, or non-numerical entries. And we have quantitative data, which is described using numerical measurements or counts. One of the ways to kind of keep the two separate is if you break the words apart. Qualitative sounds like quality, so you're describing qualities, i.e. things that are non-numerical. And in the word quantitative, like the word quantity, that should kind of get you thinking about like counts and number measurements. For instance, if we wanted to classify each of the different types of data, the amount of M&M candies in a bag, that would be quantitative, whereas the color of each car in a parking lot, things like red, silver, black, white, etc., that would be qualitative data. The next thing we're going to look at is the 4 levels of measurement, starting with the nominal level. Data at this level is going to be qualitative only. It's going to be categorized using, again, names, labels, or qualities, and no mathematical computations can be made at this level. The next step up is going to be ordinal level of measurement. This level can be either qualitative or quantitative. Data at this level can be arranged in order, they can be ranked, but the differences between entries are not meaningful. So if you're able to order things, but the differences do not have any physical meaning, then that's ordinal level of measurement. For instance, if we wanted to classify the top 5 teams in a final college football pool, that would be ordinal data. You would rank the teams 1, 2, 3, 4, and 5. So it is possible to rank them, so that makes it ordinal. However, the differences between entries are not meaningful. And what I mean by that is if you try to compare the first and second place team, the difference between those two, as opposed to the difference between the fourth and the fifth place team, even though they're both separated by 1 in the polls, the talent gap or the perceived quality difference between the two might not be consistent from one to the other. This would especially be noticeable if you had a season or a year where one team was vastly superior to everybody else. So as the number 1 team, they would vastly separate themselves, whereas there might not be too much of a difference between the 2, 3, 4, and 5 team. So again, you can rank them, but the differences between spots isn't consistent or doesn't have meaning. If we had a list of 3 political party affiliations, Republican, Democrat, and Tea Party, this would be the nominal level of data. Again, these are qualitative descriptors, and there's no way to kind of rank them in any meaningful way that describes any relationships between them other than just labels, so that makes that the nominal level of data. The next step up is going to be interval and ratio level. These both share a lot of common characteristics, but there's going to be one fundamental difference between the two. At the interval level of measurement, things can be ordered, and the meaningful differences between data values do exist and can be calculated. But at the interval level, a 0 entry simply represents a position on a scale. The entry is not what we call an inherent 0. The idea of an inherent 0, or sometimes also called a true 0, is literally the absence or the lack of that thing. The 2 classical examples that we will use in our class for interval level of measurement is going to be temperatures either in degrees Celsius or in degrees Fahrenheit. If you look at those 2 scales, it's possible to end up with temperatures that are in the negatives. So a 0 in that scale literally does not mean 0 temperature. It's just kind of an arbitrary placeholder, arbitrary position. So it's not a true 0, which would put them at the interval level. However, at the ratio level, it is possible, along with the interval level, to order things. Differences between values are meaningful. At the ratio level, we do have an inherent 0. And that means that literally 0 in that system means absolutely none of that quality. Okay. As an example, they want us to classify each data as being at the interval or ratio level of measurement. Body temperature in degrees Fahrenheit, we said this a moment ago, but Fahrenheit for us, that's our classic example of a interval level of measurement. In Part B, the heart rates in beats per minute of an athlete during an exercise session, that's going to be ratio. So at a ratio level, if somebody's heart is beating at 50 beats per minute versus someone that's heart is beating at, let's say, 100 beats per minute, the 100 beats per minute is literally twice, or the ratio of the person whose heart is beating 50 beats per minute. We do have kind of a morbid true zero in this system. Literally, if someone's heart had 0 beats, literally there'd be no heartbeat at all. So it does have a true zero there. The highest grade level completing by students, this is one that sometimes can be a little bit debatable, but whether you go from K through 12 or 1 through 12, this is going to be at the interval level. Okay, we can order them. The differences between the grade levels make sense, but it's kind of hard to define what a true zero would be here.